Hi, grade 9s. In this video, we're going to be looking at graphing linear relations. So up to this point, we have looked at patterns that are linear or nonlinear. If they were linear, we looked at how to find their equation. We've talked about how to find rate of change, an initial value, how to take a description and write an equation from that. And now we're going to take a look at how they connect with graphs. So it says here, for the pattern shown below, we have diagram 1, diagram 2, diagram 3, diagram 4. We are going to fill in the table of values and then answer a whole lot of questions. All right, so diagram number 1, well, this is diagram number 1. So I'm not going to do diagram 0. We'll come back to that. Diagram 1 has 1, 2, 3, 4, 5 squares. So diagram 1 has 5 squares. All right, diagram number 2 has 1, 2, 3, 4, 5, 6, 7, 8, 9. I know some of these look like diamonds. They're just squares that are turned sideways. So there are 9 in diagram 2. Diagram 3 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Diagram 4 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so I don't have diagram 0 and I don't have diagram 5. I could try to draw what I think diagram 5 would look like by following the pattern, or I can try to see what's going on with my numbers. So I think I'm going to look at the numbers and see if I can work it out that way. Right. On the X side, which is the left-hand side, I am going to see if I can find my differences. So to get from 1 to 2, I added 1. To get from 2 to 3, I added 1. From 3 to 4, I added 1. From 4 to 5, I added 1. On the, on the other side, to get from 5 to 9, I added 4. From 9 to 13, I added 4. And from 13 to 17, I added 4. So I think to find term 5, I would just add 4. And 17 plus 4, that's 21. And then if I was going backwards to find term 0, if I was adding 1 on the other side, I would subtract 1 to go backwards. And then on the Y side, instead of adding 4, I would subtract 4. Sorry. 5 take away 4 is 1. Okay. So it says, determine whether the pattern is linear or nonlinear. This is linear because the differences are the same on each side. So these I'm not including because that was just me working backwards. So I'm going to say this is linear. All right, state the initial value. The initial value is term 0. So my term 0 or diagram 0 had 1 square. So my initial value would be 1 square. The rate of change is how much we are going up by for every 1 on the X side. So we are going up 4 squares per diagram. So to do rate of change, we often do delta y divided by delta x. I normally don't like writing my equal signs all beside each other, but I don't have enough space. So it is 4 divided by 1, which is 4 squares per diagram. So we are going up 4 squares for every diagram we add on. All right, plot the points on the grid. So there is a grid here, right? On the x-axis, we have numbers. On the y-axis, we have numbers. On the x-axis, we are going to put the diagram. And then on the y-axis, we are going to put number of squares. Okay. All right, so up first we have 0 and 1. So 0 would be here, where the X and Y axis meet. And I notice on the Y axis, we're going up by ones. So 0 and 1 is just that first line. Then I have 1 and 5. So 1 is in between 0 and 2, and 5 is right there. 2 and 9. That's the one right before 10. 3, there's 10, 11, 12, 13. 4, and there's 15, 16, 17. And then 5, and 21 is right above 20. Okay, so taking a look at that, I see that the points do make a fairly nice straight line, which makes sense because it is supposed to be linear. The next step asks you to draw a line of best fit through the points. So there are rulers up at the front on the white shelf that you're welcome to use if you need to, but you might want to wait till we're done this part to go grab them. I am going to take my ruler, and because it is linear, I am going to line all of my points up with my ruler, and I'm going to draw a line so that it goes all the way to the very end of my grid. Okay, so you want to line up with your points, and then I'm going to draw a line that goes all the way from one side of the grid to the other, and then I'm going to put an arrow on the end to show that it continues on in both directions. Right? The nice thing about having a line is that it allows me to find points that are further up without me having to calculate them, right? Or if I wanted to try to calculate a value in between 2 points, I can do that, right? The line allows me to be able to see more values on the graph than the points that I plotted in my table. Okay, it says, where on the graph can you see the initial value? So we said the initial value was 1 square. So 1 square is right here, right? So my initial value is always the term 0, right? So x would be 0. So it's always going to be where the line crosses the y-axis. So the initial value is where the line crosses the y-axis. So I'm going to say where the line, I'm going to say meets the y-axis. All right, and then it says, where on the graph can you see the rate of change? So the rate of change looks at how much did I go up or down by to get from one point to the next. So if I started at my initial value, I noticed that to get to the next marked point, we went up 1, 2, 3, 4, and over 1, right? So I went up 4, and then I went over 1, which if we look at our table of values, right, on the y side, we were going up 4, and on the x side, we were going over 1, right? And then from here, I would go up 1, 2, 3, 4, over 1. Then we went up 1, 2, 3, 4, over 1. So every time we're going up 4 squares per one diagram, right? So you can see that the distance between the points, how far up, how far over, that is our rate of change, right? So where on the graph can you see the rate of change? So I'm going to say it's the distance between the 2 points. Let's say between one point and the next. Not sure that distance was the right word to use there. It's more the pattern that we're following to get from one point to the next. Right? It's how we're counting from one point to the next. Okay, I think I am going to stop this part of the video, and then I will start the next video on the next page. See you in a minute.